All right, remote kids, good morning. This is the top graph on your knowing slope versus finding slope worksheet. And I just kind of want to get you started on it because it's a bit more aggressive, I guess, than any of our other functions to kind of, because the first thing it asks you to do is sketch the graph of the derivative of f of x on top of this. And once you've done that, then you can go down and answer the questions A through G. Know that if your derivative graph looks a little bit different than mine, which it very likely could, and I'll talk about when that happens or could happen, then some of your answers will be a little bit different, because if you're using the graph to answer your questions and your graph is slightly different, that's fine. So I'm going to do the derivative graph in red, and again I'm going to highlight, if this is my function, the first thing I know is anywhere there is a min or a max, then the derivative is going to have a 0 there. So I know that this is a min, so I know the derivative is going to have a 0 because the slope is 0. Here the slope is 0, so I'm going to have a derivative will have a 0. Same here, that's a min, so I know my derivative function will have a 0. This is a weird point, I'm going to talk about that in a minute. This is a max, so the derivative would have a 0. And notice this is not a min or a max, but as it levels off and it keeps going up, there's definitely a horizontal tangent line here. So even though that's not a min or a max, it would give my derivative a 0 as well. So the next piece I'm going to do is I'm going to talk about the fact that these are all negative slopes. So that means that the derivative would be a negative output value. So my derivative graph has to come up from below. Then all of these are positive slopes. So it's going to be above. But notice right there, they become negative slopes again. So somewhere in between here and here, I have to switch and turn so that I can get back underneath. And we're going to talk about that more next class, but like right about here is where the concavity switches. And so that x value is where I would have a possible turning point on my derivative. So that's where your graph might look a little different than mine, because you may put that, we don't know exactly where that happens, it just happens along this x value. So like maybe it happens up here, who knows? So if I put mine, maybe I'll put mine down low, maybe I'll put it about right here. So I'll put it with like a little x. So that's where I have to turn and come back down. This is supposed to be smooth, by the way. And again, these are all positive. It just is getting less and less positive now, all the way to here. I'm negative. So again, somewhere in between here and here, I've got to turn so I can come back up. So again, that happens somewhere in the middle here when I'm concave down and become concave up. So who knows, maybe I'll put mine way down here. Again, you could put that anywhere underneath here on this x value, or right around that x value. We don't even know exactly where it is, but that's where your graph could differ. Where you put your peak here could be up here. This one you could put down here, so that'll change it. What doesn't change is where the x-intercepts are and the fact that you've got to turn somewhere in between them. So now notice these are all positive up to here. So again, somewhere in between here, this is concave up, then it's concave down. So I'm just going to right about there. Again, you could put it anywhere along here. I'm going to come back down, and here's where it gets tricky. These are positive slopes, slope is 0, and then these are positive slopes again until here. So actually, I'm not going to cross under because my slopes turn and continue to be positive. So I actually bounce at that x-intercept. That's kind of why I wanted to show you this. And again, somewhere in between here, I change concavity. Maybe this one goes way up here and then comes back down and crosses right there. Boom. So this is my derivative graph, f prime of x. Yours could look a little bit different in terms of where your derivative peaks, mins and maxes are, and your end behavior should be the same as mine, and your x-intercept should be the same, but it could change answering some of your questions if you use your graph. All right, try to answer A through G. I will post an answer key so you can kind of check as you go, and also there's page 2 that I want you to do. You do not have to do that third page, that Desmos activity. We're going to do that later.